Hi dear students, in our last lecture we seen hardness of water, types of water, then types of hard water, and in that we seen hard water having a two types, and first one is the temporary hardness and second one is a permanent hardness, and we already seen how to remove it. And in that we seen that temporary hardness can be removed on boiling, so here, for example, one normal water sample is given to you without any kind of treatment on that water sample. So that water sample containing both types of hardness, temporary as well as permanent type of hardness. So normal, or you can say untreated water sample will give you total hardness. Which word I am using? Total hardness. So total hardness, who is responsible for that? Temporary as well as permanent hardness. So here, if we boil the water sample, we know temporary hardness causing chemicals convert into insoluble products on boiling. That is what? On boiling, temporary hardness causing chemical get precipitate out, and that precipitate we can remove on filtration. So simply, normal water sample, you boil it, and after boiling, filter it. After filtration, temporary hardness gets removed, or it will left behind on the surface of filter, and what will come out? Only permanent hardness causing chemical will come out along with water, and temporary hardness causing chemicals will left behind at the surface of filter paper. So dear students, boiled and filtered water sample, if you take for titration, then that boiled and filtered water sample will give you only permanent hardness. Okay, so here, if you want to find temporary hardness, then simply you have to subtract permanent hardness value from total hardness. Okay, so temporary hardness formula. So temporary hardness is equal to total hardness minus permanent hardness, because here by using a titration method in practical, you can get value of total hardness and permanent hardness, and after subtraction you will get value of temporary hardness. So here we will see the units of hardness, means once you get the value of hardness, then what kind of unit you are going to use. So as you know very well that the hardness is due to presence of dissolved salts. And as you know that salts are different types. Salts are having a different types like calcium chloride, magnesium chloride, iron sulfate, calcium sulfate, magnesium nitrite, right? So different kinds of salts are there, and they are responsible to make water hard. So it becomes very difficult to express them separately, because number of salts are there and salts responsible to make water hard. So how we can express them individually, separately? It becomes very difficult. So here, for more convenience, what we did, all of them are conveniently expressed in terms of only one chemical. So what is that chemical? And that chemical is calcium carbonate. So calcium carbonate is the only one chemical that we use to express the hardness of all types of hardness causing salts. What is the speciality of calcium carbonate and why it is selected? Because first thing, calcium carbonate is practically insoluble in water. Calcium carbonate, first thing, practically insoluble in water. Second thing, its molecular weight is 100 and equivalent weight is 50. So molecular weight 100, equivalent weight is 50, and these weights are much more convenient to take for calculation. Okay, so these are the two reasons. That's why calcium carbonate is used to express the hardness of water sample, and that hardness because of various kinds of salts. So what is the formula? Quantity in terms of magnesium carbonate, quantity in terms of quantity in terms of milligram calcium carbonate, milligram calcium carbonate, which is equal to milligram of chemical. So milligram of chemical value will be given to you. So you just put milligram of chemical value multiply by 50. What is the 50? Equivalent weight of calcium carbonate. So you are taking a 50, that's why we divide it by equivalent weight of chemical. Okay, so formula is a milligram of chemical, this value will be given multiply by equivalent weight of calcium carbonate, right, divide by equivalent weight of the chemical. Which chemical? So the quantity of chemical is given in the milligram, so that chemical equivalent weight you have to take. So if you take 100 instead of 50, then you have to divide by molecular weight of chemical, keep in mind. So if 50 is there, then equivalent weight of chemical, and if 100 is there, then molecular weight of the chemical. Alright, so units of hardness, in that first unit is ppm. Okay, that is what the parts per million, and parts per million, that is what the 10 raised to 6 parts of water. Okay, so here you keep in mind 1 ppm CaCO3 equivalent, that is what 1 part of CaCO3, right, in 10 raised to 6 parts of water. So here simply you keep in mind ppm, that's it. ppm is the unit that is used. Second one is a milligram per liter, milligram per liter, and here relation between ppm and milligram is 1 ppm CaCO3 equivalent, which is equal to 1 milligram CaCO3 equivalent per liter. So 1. Then third unit, that is not useful, but just for information, it is a ppb, parts per billion. So one example, here some hardness causing salts are given to you, like magnesium sulfate, calcium sulfate, magnesium carbonate, calcium carbonate. Their weight is given in milligram and their equivalent weight is also given. So magnesium sulfate 34, calcium sulfate 28.2, magnesium carbonate 4, calcium bicarbonate 14.2, and their equivalent weights are given. So here your task is to identify, first thing you have to identify which chemical responsible to make water temporarily hard, right? Means you have to make two groups. In first group you have to enlist hardness causing chemical, that is a temporary hardness causing chemical, and in second group permanent hardness causing chemical. So as you know very well that temporary hardness because of what, and who responsible for it? Temporary hardness because of soluble carbonates and bicarbonates. So in examples you see here is a carbonate and bicarbonate. So last two example, magnesium carbonate and calcium bicarbonate, these two responsible for temporary hardness, and first two chemicals, that is what magnesium sulfate and calcium sulfate, these two responsible for permanent hardness. Okay, so two separate groups, temporary hardness, permanent hardness, and formula is very simple as we seen just now, that the milligram of chemical multiply by 50 divided by equivalent weight of chemical. So by using this formula you can find hardness of individual chemicals, then that individual value you have to add. For example, for permanent, magnesium sulfate and calcium sulfate responsible. So these two chemicals individual values you have to add, so you will get permanent value. And magnesium carbonate and calcium bicarbonate individual values you have to calculate and you have to add it, then you will get temporary hardness value. Then you have to add all chemical hardness value. What I am saying, you have to add all chemicals hardness value, then you will get answer of total hardness. So in this way you have to solve this numerical. Okay dear students, so in next lecture we will see how to determine hardness of water sample by EDTA method. Okay, so thanks for watching.